This next section is on IQR, histograms, box plot, and dot plot. What these all are is different ways to show data and to show the trends in the data. So the first thing that we're going to look at is interquartile range. And what that means is it's the difference between the third and first quartiles. And we're going to figure out, well, what is even a quartile? So when you're finding the interquartile range, the first thing that you want to do is put the data in order from least to greatest, which we've done. And then we're going to identify the median. So looking at, we have we have 15 pieces of data, which means that if we go in on 7 from both sides, that 5 would be our median. So 5 is the median. So you want to identify the median. And then what you're going to do is look at the lower quartile of data, which is the lower half, and the upper quartile of data, which is the upper half. And from there, the quartile 1 and quartile 3 are just the median of each quartile. So again, this is the lower quartile, and then we also have the upper quartile. And this will be in the video at the end again, because it's kind of a lot to take in. So quartile 1 is going to be the median of the lower quartile. So this would be Q1. And then quartile 3 would be the median of the upper quartile. And the median, you can also think of that as quartile 2. So the interquartile range, or IQR, is equal to the third quartile minus the first quartile. So in this case, it would be 7 minus 3, which is 4. So just again, to review that, to find the interquartile range, you put the data in order from least to greatest. You identify the median, and then you look at the upper half of data and the lower half of data. From there, you find the median of the upper half and the median of the lower half, and that will give you your Q1 and Q3, and then you would do quartile 3 minus quartile 1. The next thing we're going to look at is the dot plot. So this is a way to show data. So a dot plot is a data representation that uses the number lines and X's or dots to show frequency. So to save time here, I already put our data in order from least to greatest, and typically anytime you have data, that should be your first step, is to order it from least to greatest, because you'll have to do that to find many aspects of it. So this data represents salary in thousands of dollars. So to do a dot plot, what you're going to do is draw a number line, and then you want to make sure you have an x-axis, which represents the data. So it looks like our lowest entry is 25 and our highest entry is 65. So I'm going to go by 5s, starting with 20, and then I'll just show every 10. So this will be probably the hardest part, is just kind of knowing how to set up, but the more practice you get, more used to it. And then from there, you just either put X's or dots to show the frequency. So for example, 25, we have 125. And then we go to 30, we have 130. 35, we have 3 35s. 40, we have 3 40s. 45, we have 3 45s. We have 150, we have 160, and we have 165. So this will show us another way to show the spread of data. So again, you set up your number line, and then you just indicate the frequency of that point. All right, next one is a histogram. A histogram is a bar graph that is used to display the frequency of data divided into equal intervals. So I have the exact same data listed here from the previous problem, and we're just going to show a different representation of the data. So again, this represents salary in thousands. So a lot of people might be familiar with this. It does look similar to a bar graph, except they are right next to each other, and then you have the exact same intervals. So you're going to set up an L-shaped graph. The x-axis will be salary in thousands. And I should probably leave a little bit more room. So this will be salary in thousands of dollars. And then the y-axis will be frequency. So this is pretty similar to the dot plot in the fact that it's showing the frequency or the amount of time a data point occurs. The only difference is we're going to do a range of values. So looking at this, we have values that go from 25 to 65. So I'm not going to have every single entry, for example, 25, 30, 35, like I would in a dot plot. So I want to do a range. Now I could do something like 25 to 30, 31 to 35. However, that would be a lot of entries, so I'm going to go by tens. So I'm going to start with 21 to 30 will be my first part, and then I could do 31 to 40, then 41 to 50, 51 to 60, and then lastly 61 to 70. And then the y-axis is going to be frequency. And so I know that we'll kind of guess, but I'm going to go till about 6. All right, so we want to look how many entries are between 21 and 30, and according to our data, there are 2. So you're just going to go up to 2. Between 31 and 40, we have 6. So I have to go all the way up to 6. Between 41 and 50, we have 4. Between 51 and 60, we have 1. And between 61 and 70, we also have 1. Okay, so what's really important here is that the bars are touching one another. And the other thing is that the ranges you choose on the x-axis are the same. So for example, you couldn't do something like 21 to 30 and then go 31 to 50. So it needs to be the same increments of numbers. All right, the last thing is a box plot. So this one's probably the most complicated. So again, if this is a little bit confusing, you can always watch this again, and then I have the notes attached as well. So a box plot shows how the values in a data set are distributed. So we have here a whole bunch of data which represents the number of runs scored by a softball team for 20 games. So this is going to be a step-by-step process, and the first step is to order the data from least to greatest. And like I said in the beginning of the video, that's going to generally be the first step of anything with this when you're analyzing data. So we have all of the data. I already saved time, so I ordered them from least to greatest. The second step is to find the median, min, maximum, Q1, and Q3. So I list them out again because I'm going to use this to kind of break it apart. So if I need to find like the quartile 1 and quartile 3, I need to find the median. However, I already know because there's 20 pieces of data that this will not be an odd number, and therefore I can't find the exact middle number. So I have to look at 2 numbers and average them. So when you do that, if you count 10 in from both sides, it ends up being here. So this is the median. So the median would be 7.5. So again, you look at the data in order and then pick the middle number. So I now know that the median is 7.5. Now we're going to look at the lower set of data and the upper set of data. But I'm doing this one for a reason because it has an even amount. You do include that number. So when you have an actual true median, you don't include the number. So I'm going to go back up to our first example When we had a true median, I don't include the number because it doesn't make sense because I can't go with both of them. But in this case, I include it in the lower and upper quartile. So I can answer the fact that there's a minimum at 2 and also that there is a maximum at 14. Now, quartile 1, remember, is the median of the lower half of the data. So in the lower half, I have 10 pieces of data. So in order to find the median, I know I'm going to have to average those middle pieces, which are 4 and 4. Well, the average of 4 is just 4. So quartile 1 is 4. And then I do the same thing for the upper set of data. So it would be the middle part, which is quartile 3, and the average of 10 and 10 is just 10. Now, if I wanted to find the interquartile range, I would just do 10 minus 4. Okay, so the next step is to actually set this up. So we're going to set up using a number line, and it needs to have enough numbers to represent everything in the data. So we have numbers ranging from 2 to 14. So I'm just going to go ahead and start at 0, and then I will identify every 2 because that should be enough to show us all of the data. Perfect. Okay, so it's also been known to call it a box and whisker graph. So the first thing that you're going to do is put a dot at the minimum and maximum. So we have a minimum, and I'm kind of starting up on purpose, at 2, and then we have a maximum at 14. Okay. Then you're going to go ahead and put a line at quartile 1. So quartile 1 is 4, so that's going to be the end of the box. And quartile 3 is 10, so that's going to be the end of the other box. Okay? And then you're going to go ahead and connect that box, connect the dot to the end of the box. And lastly, the median goes in the middle, which is 7.5. So that would be between 7 and 8. And there you have it. So you do need to know that this is the minimum. This is Q1. This is your median. This is Q3. And this is your maximum. And so what this means is this portion right here, that represents 50% of the data. And then the lower part represents 25%, and then the upper part represents the other 25%. So here we have all the different ways to show data.